Okay, in the previous class, we were discussing about some statement problems on applications of derivatives. So we'll continue with a few more examples. So the next question is this. So show that of all the rectangles inscribed in a given fixed circle, the square has the maximum area. So that's the question that is being asked over here. So you're having a circle. So you have a circle, and then in this you're having a square. So this is a circle that is we are having. This is the center of the circle. Now we just try to join a line from here to here. This gives us the diameter. This is the center of the circle. So outside you're having circle. Inside the circle you can draw the rectangles. Now rectangles can be drawn in different ways, right? Suppose I can draw the rectangle in this way. So a rectangle is inscribed. Or I can draw the rectangle in this way. So many number of rectangles can be drawn, but what he says is of all the rectangles that you are inscribing inside the circle, the maximum area will be of this square only. So this square will have the maximum area, whereas all the other rectangles will be having minimum area. So that is what we need to check, that this square that we have created should have the maximum area. So the rectangle which we have taken, that rectangle we have to show that it is a square. And it is having the maximum area we have to show. So if you want, we can take this as say A, B, C, and this is D, right? Now from D to O, that represents the radius of the circle. From O to B also represents R, the radius of the circle. Now these are the 4 points A, B, C, and D on the circumference of the circle, right? Diameter is BD and its value will be R plus R will give us 2R. That will be the diameter of the given circle, right? But if you try to observe, and we have to show that this ABCD is a square. As of now, what he has given over here is rectangles are inscribed. If I'm taking a rectangle, the rectangle will have some length. Let us take the length to be X, breadth to be Y. So we'll start the solution by writing down, let the length of the rectangle be equals to X, and the breadth of, let the breadth of the rectangle be equals to Y. I have to convert the two unknowns into only one unknown. So how to convert that one unknown? I'll retain this value of X as it is and try to get the value of Y. So how can I get the value of Y in terms of X I have to get? But X and Y you are having only over here. This DC is a side length and BC is the breadth Y. So I have to express in terms of X and Y only. So if that is the case, if you try to observe this triangle, from triangle BCD. So BCD will be what type of triangle? Suppose if I'm taking this as say 90-degree over here. So BCD will be right angle triangle. If it is BCD is a right angle triangle, then we can apply the Pythagoras theorem from triangle BCD. Now this is a right angled triangle. Right angled triangle. So we know the hypotenuse square, that is BD square, is equals to, it is BC square plus DC square. Just by using the Pythagoras theorem. What is BD value? BD value is R plus R, which is 2R. And calculated over here, it is 2R whole square is equals to BC. What is BC? BC value is Y. So it is Y square plus DC. What is DC here? DC is X. It is X square. So I have to find out the value of Y, because X I'll retain as it is. I'll try to find out the value of y. So retain this y square as it is. Send this x square on the other side. And also try to remove this square. 2 square will be 4 and it is r square, 4r square. And I'm sending this plus x square on the left hand side, it becomes minus of x square. Hence, we have got the value of y square to be equals to this 4r square minus of x square. Therefore, the value of y will be square, goes on the other side, becomes square root. So whether it will be plus or minus, it is 4r square minus of x square. Because y is a breadth, it will only be positive value. Therefore, we'll just try to consider the positive value. Y is equals to, it is root of 4r square minus of x square. So x is the length and the breadth y has been expressed in the form of x only. So both the values have been obtained. But what he says is we need to actually maximize the area of the rectangle. So given ABCD is a rectangle. It is given a rectangle, but we have to show that it is a square. ABCD is a rectangle, therefore area of the rectangle. What is the area of the rectangle? So area of the rectangle will be length into breadth. Length is what we have taken. Let me take the area of the rectangle as A. Length we have taken it as X. Breadth is Y. But Y value we have obtained over here. Y is root of, let us write down, X into Y is root of 4r square minus of X square. But since we are having square root, actually whenever you have square root, differentiation will become difficult for us. Therefore, it is better we try to square this one. Squaring on both sides. Squaring on both sides. So if we square on both sides, it becomes a square is equals to x will become square, root will cancel out, we'll just be getting 4r square minus of x square. Right? Let me take this a square because a square again differentiation will become difficult for us. So let me take this value to be equals to some we're calculating area. Let me take that as z. Z is equals to a square. Therefore, z will be, what is a square value that we have obtained? It is x square into 4r square minus of x square. So z has been obtained, but for finding out the maxima or minima, you have to first find out the value of x. So to find out the value of x, you have to differentiate this one. So you have to differentiate this with respect to what? Because r is the radius. So we have to differentiate this with respect to the radius. So let us try to differentiate this one. So differentiate. So now the question is whether we have to differentiate with respect to the radius or whether we have to differentiate with respect to x. So we want to find out x, therefore differentiate z with respect to x. The try to differentiate becomes dz by dx will be equals to. Now we need to use the product tool over here. So this will be, or it is better, I'll try to multiply this one. Before I go for this one, I'll try to multiply. Let me multiply this x square inside. It becomes what? 4 as it is. It becomes r square x square. Then minus, multiply this x square into x square will give you x power of 4. So just multiplied and rewritten in that form. Now let us try to differentiate this one. So if you try to differentiate with respect to x over here, you will be getting 4r square as it is because it is a constant. Differentiation of x square will give you 2x. Minus x power of 4 is there. Differentiation of x power of 4 will be 4x cube. Or if I try to multiply 4 times of 2 is 8. 8r square x minus 4x cube. But to find out the value of x, we have to consider dz by dx to be 0. Consider dz by dx to be 0. So, but dz by dx is this 8r square x minus 4x cube is equals to 0. But if you try to observe over here, x is common, I can take x common, I'll be left out with 8r square minus 4. Out of x cube, 1x is gone, 1x square is left out, is equals to 0. Now I can put x as 0 there, one value, then 8r square minus 4x square will be 0. So because I want to find out x, I'll retain this minus 4x square as it is. send this value of 8r square on the right hand side. 8r square, you're having plus 8r square. When this plus 8r square goes on the other side, it becomes minus 8r square. Or x square will be minus 8r square. Cross multiply, that will give you divided by minus of 4. But further, if you try to simplify this one, it is 4 ones are 4, 4 twos are 8. Along with the negative sign, it will cancel out. So x square will be, negative sign has gone, this 2 is there, so 2, and this r square. Or x will be equals to, it is plus or minus, represents the length. We'll just be taking the positive value, root 2, and this, are you getting this? Substitute x in equation number 1. Substitute this value back over here, y will be equals to, this is 4r square minus root, this root and square will get cancelled, just be getting 2 there. And this is r square. So hence we have 4r square minus 2r square will be 2r square under root. Or y will be equals to, this root 2. This r square, the square and root will get cancelled, just be getting r. So the value of y will be root 2 r. So we have got two values, x to be equals to root 2 r, y also equals to root 2 r. So what does this mean? X and y are the same. Here we got x is equals to y is equals to how much? Root 2 r. That means length and breadth are the same. X represents length, y represents breadth. Getting it? Therefore, since x is equals to y, that is length is equals to breadth. Under which figure you have length and breadth as the same? It is a square itself. X is equals to y. Therefore, the rectangle inscribed, right? A rectangle inscribed is a square. But is it a maximum or not? We have to check. Whether it is maximum or not. For maximum or minimum, you have to go for d square y by dx square. So here what we have taken, dz by dx you calculated. This one, you have to differentiate again. Let me take this as equation number 2. So to find maximum, that means whatever square you have got, this itself is the maximum you have to show. To show that the square has maximum area. The square has maximum area. So we'll try to differentiate equation number 2. Equation 2 with respect to x. So let us write down what is that equation 2. We have dz by dx. I'll just try to rewrite that one here. 8r square x minus 4x cubed. Now we need to differentiate this one. If you try to differentiate, it becomes d square z by dx square is equals to 8r square is a constant. Differentiation of x with respect to x will be 1 minus 4 into differentiation of x cube will be 3x square, or 8r square into 1 will be 8r square itself, minus 4 times of 3 will be 12. So 12x square. That's the value you're having. But now again, I need to just try to plug in this value of x that we have obtained and just try to check what is the value that you'll be getting over here. Right, this x is root 2r, and it is squared. Since x is equals to root 2r, we are having. Now if we try to simplify 8r square minus, it is 12 times of, but this root and square will get cancelled, will just be left out with 2, and this is r square. Or further, if you try to simplify this one, it is 8r square minus 12 to the 24. This 24r square. Or if you try to subtract this, you'll be getting minus 16r square. R is a radius, and radius will be positive if r square is a positive value. A positive and 16 is also positive. When a positive value is multiplied by negative, you'll be getting negative value. Therefore, this value which is there is less than 0. So whenever you have d square z by dx square less than 0, d square z by dx square is less than 0, we can say that the function is z is maximum. Z is maximum, we got the square. Since x is equals to y, therefore the square has the maximum area. The square has the maximum area. That's the required solution. Getting it?